Hola, Madrid. Thank you so much for coming to this session. I'm really excited about the topic that I'm going to share with you today. I'm talking about service workers. But today, I actually want to start us off with a question. How many of you have heard of Atwood's Law by a show of hands? Okay, not many of you. That's unfortunate. So Atwood's Law comes from Jeff Atwood, who's better known online as Coding Horror. And it simply states that any application that can be written in JavaScript will eventually be written in JavaScript. Now, I first said this about 11 years ago, and at the time it was kind of just a funny observation. But as the years have gone on and JavaScript has evolved and become more and more prevalent, it's become remarkably accurate, right? We now have our chat applications written in JavaScript. We have our music players written in JavaScript. We even do our coding in tools written in JavaScript now. But that's not all, right? We can also recreate old applications like Winamp completely in the browser. And now we're seeing even more amazing applications come out with the advent of progressive web applications. And that's really what I want to talk about today, because progressive web applications are awesome. They're basically supercharged web apps, right? They give us the ability to serve content offline, deliver push notifications, and do other things that previously were relegated to only native applications. And that's exciting to me. And at the heart of them is service workers. But we often only talk about a small subset of features that service workers bring to the table. And so today, I want to talk about some ideas that I think are really fun and exciting, even if they might be a bit complicated and maybe a bit scary in some ways because they're pretty advanced. But service workers are amazingly powerful. And so today, I want us to delve into this odd world and explore what we can do with that power outside of just building progressive web apps. But before we jump into all that, who am I? My name is Trent, Willis, and currently I work at Netflix as a senior UI engineer. But more importantly than that, and for today, I'm really just someone that loves the web, loves web development, and I love JavaScript because there's a lot of freedom and creativity that we can find in this development environment. And what's really exciting to me about this particular moment in web development history is that JavaScript is evolving so rapidly, and there are so many opportunities for us to be creative and experiment with the tools that are at our disposal. And so that's really what spurred on this talk. I found an interesting bit of information about what you can now do on the web platform and decided to start exploring that. And eventually it evolved into the content of this talk. And so what was that interesting piece of information that I discovered? Well, earlier in the year, I was reading a specification from the Web HYPERTEXT Application Technology Working Group. That name is a mouthful, and so it's more commonly known as WHATWG, and you might have seen this name floating around on the internet from time to time. And I was reading their specification that they had put out for the Streams API. The Streams API aims to provide a way for the web platform to easily interact with and consume streaming data. This is something that's pretty common in the Node.js world. You might have encountered streams there, especially if you use a build tool like Gulp. But up until recently, there was no primitive for this on the web platform. But that's changed. Now, the really interesting part is, as I was reading the specification, in the introduction, they identify a really peculiar use case. And that is, if a stream is installed inside the fetch hook of a service worker, you could actually transparently polyfill new image formats. And this got me thinking, that's pretty awesome. Polyfilling image formats, modifying browser behavior in that way used to not be really easy. And as I thought about this more, I realized you could use this technique actually to polyfill any sort of file format on the web. Not just images, but you could also do video formats, or maybe audio encodings. Or what about new types of code that you could compile and serve on the browser? But that's getting a little ahead of myself. How is this actually possible using service workers? Well, so let's take a step back and imagine we have a new image format, a file in this new format that we want to serve. If we were to polyfill that, we'd want to be able to use it in the browser as we would any normal image, using an image tag, and then specifying the image path and its file extension. But we know that this won't actually work in the browser right now because the browser can only render PNGs, JPEGs, GIFs, file formats that it actually understands, not a .nif file like this example shows. And so that means in order for this to actually work, if we're loading this file from our servers, we need to translate it into something the browser can understand before it tries to render it. And so the answer to do this is to use service workers. Now, many of us are familiar with service workers as a way to serve content offline or add push notifications or get that add to home screen prompt on your mobile devices. Progressive web app functionality, right? But what many of us don't think of them as is actually a middleman or a proxy that sits between our application and our servers or our CDNs. And when we think about them in this light, it becomes a lot easier to see how we might be able to transform that response that we're getting back from our server. And so in this example, we get a .nif file from our server, but on its way back to the client, we can simply transform it into a GIF or a PNG or some other format that the browser actually understands. So this is the high-level idea. Let's dive into the code of how we would actually make this work. Before doing that, though, I want to add a word of caution in that all this code will be available online. Don't worry about the specific details or taking a whole bunch of detailed notes. You can find all the examples online later and study them to your heart's content. Easy way to do that will be to follow me on Twitter, where I'll be sharing links to all this stuff later on in the day. Cool, so let's dive in. We're going to start by registering a service worker in our application. You do this using the standard navigator.serviceworker.register API. I like to be very explicit in my file naming, so I simply name my file service-worker.js. Now in that file, there are two concepts that we need to know and be familiar with. The first is known as the fetch event, and so we add a fetch event handler here. A fetch event is simply a JavaScript event that is emitted anytime the browser makes any sort of request. That doesn't just include JavaScript requests like XHR objects or methods calling the fetch method, but even things like your page's HTML when it loads, or images that it's fetching, or style sheets that it's loading. These events are emitted for every single request, and they contain a bunch of information about those requests, including things like the URL that's being requested, the method that the browser is using to get that resource, and so forth. But by default, adding this hook doesn't do anything for us. It just lets us see the events as they're coming through. But we actually want to do something, transform that request, right? And so the second API we need to be familiar with is the respond with method. And this is a method that actually comes by default on all fetch event objects. And basically what it says is, hey, instead of responding with the normal network response that you were going to get, respond with this other value that I'm going to give you instead. And this is really powerful because this is actually how we implement the ability to serve offline content. We intercept the request and say, hey, instead of going to the network, take this other value I have in my cache and respond with that instead. And so we can use and potentially abuse this to do all sorts of fun stuff in the browser now. So what we're going to do, and what we'll look at implementing in a second, is a function that basically just says, hey, take this request that I'm for a file format that's not supported by the browser and polyfill it into something that is supported by the browser. Now, of course, if you do this, you're going to want to add a guard here. You don't want to do this for every request, just for requests that are actually matching the type of thing that you want to polyfill. So let's dive into this function. So the method that transforms our request into something the browser supports can take many different shapes, but in general, I like to follow this pattern. You start by fetching the original request using the service workers fetch API. And to do this, you can just pass the original request object you got. Pretty simple. You then take the response from that, and you can access its data in some form. You can use a method like .json if you're dealing with JSON data, or more commonly, if you're dealing with a code file or an image, you might want to use .blob or .text, or maybe even .array buffer. Once you have that data, you can then simply modify it into whatever format you need for the browser to understand, and then you craft a new response object from it. And then finally, you return that response object. And then you can actually implement demos like this one. So here's a demo of a file of an image format I implemented that is actually serving an encrypted image. And so by default, if you try to load this up in the browser, you get a broken image. And now, that's not really great. But if we go and actually enable a service worker for this page and reload it, you should get a working image. And now this is really exciting to me because it shows that what they said in the specification wasn't just a theory, but it's actually possible today and in modern browsers. And I tried this out in Firefox and Safari. It works there as well. And so that's awesome. So you can find this demo online at cryptogram-naive.glitch.me. And so check it out at some point later if you're interested in some more of the details of how I implemented this. Particularly if you're interested in the cryptographic aspects of the encrypted image, it's kind of cool. But what else could we do using this technique? What if we could polyfill extensions to the entire browser platform? So I work a lot with web components, and one of the things that I really want to be able to do is import my HTML templates into my JavaScript files so that way I can easily add them to my components. But by default, you can't do that in the browser. But using this technique, we could actually polyfill the ability to load HTML modules into our JavaScript code. And so here's a little demo that I put together where we actually start by looking at an HTML template, importing it into a JavaScript module, and then loading it up in the browser. And this works. There is no build happening here. It is just code that is running in the browser. So the ability to polyfill any type of file like this offers a lot of ways for us to experiment and be creative and think about ways that we can push the web platform forward. Now, some of these ideas may not be great to try out in production, but you can at least have fun and experiment. So you can find this demo online as well at html-modules-polyfill.glitch.me. So go check it out if you're interested. What else could we do, though? If we take that last example and think about importing HTML into our JavaScript and think a bit more broadly, really what we have here is a solution to polyfill or support running any code at runtime in the browser, if you can compile it to something the browser understands, like JavaScript. Which is to say that one application of this would actually be able to run TypeScript in the browser. I love working with TypeScript. I think it's a really great tool, but I hate having to set up a build process anytime I want to prototype something in it. So what if I could just do this instead and load a .ts.typescript file right up into the browser? And what if I could use the modern module syntax with it too? You can actually do this using the techniques that I just described. And it's really fun. I'm excited to continue pursuing this so that I can use TypeScript in all of my just random projects that I decide to spin up quickly. And you can do this with any code that's compiled, such as Babel code or code that's implementing features that the browser hasn't yet supported. However, there is a catch here, right? If you're working on a large project, compiling all the code every single time you visit a page is going to be slow. And so we really need another API that service workers have brought to the browsers as well. And that is the cache API or cache storage API, which, as its name implies, allows you to cache objects in the browser, but only a specific type of object. The caches API is specifically designed to allow you to cache response objects from requests that the browser has made. Things such as your source code or images. But you could also cache the transformed or compiled code that we can serve in our TypeScript example that'll be coming up. So what we want to do is we want to think about only compiling the modules that have changed. And we can do that with the caches API. So let's say we have a function that we're using in our service worker, and we'll call it compile with cache. It simply takes in a response object and compiles its data with a passed-in function. So we're going to start by calling the caches.open method, which is simply going to open up a new namespace cache for you. All the caches are namespace, so that way you can potentially avoid conflicts if your service worker is running on multiple pages at once. But that's all the name is really for. And so we open up our cache, and once we have it, we can check to see if the status of our response is simply a 304. And if so, then that means we know that the file hasn't changed since the last time we loaded it. Now, you might need to implement some more complex cache checking logic, but this works for some simple use cases like a demo on glitch. If the value hasn't changed, then we're going to call caches.match and look for a response object that matches the URL of the request that we just made. Now, there is a typo in this slide, which I forgot to fix before presenting, and that is instead of request.url, it should be response.url. But you could even use the request object as well. The browser is smart enough to still figure out that it's the same URL. So in the case where we don't have, or where we have a changed file, one that didn't return a 304, we'll want to compile the response. And so if you're using TypeScript, you'd want to use the TSC compiler, but you could use any other compile method, even a custom one that you wrote, and then put that object into the cache. Now, one interesting thing to note here is that you have to call the clone method on our response object. And the reason for this is the browser can only use a response object for one thing. So if you put it into the cache, that counts as its one thing. And so we have this handy clone method to duplicate it, so that way we can put it into the cache as well as return it to the browser to actually use for whatever else it needs to use it for. Anyways, once we put it into our cache, we return the original compiled response into our method that we had earlier to event.respondWith, and we proceed on. And so to show that this isn't just a bunch of stuff that I'm making up or another theoretical concept, here's a demo of this actually running in the browser. So we have some really simple TypeScript files here with simple TypeScript annotations. And we can check out that when we load them up into the browser, that it actually loads. And we're not compiling the ones that haven't changed since the last time I worked on it. But we can also go through and make a small change. And when we do that, we'll see that we only recompile the one that has changed. And so this is exciting to me. Like I said, I love TypeScript, and working with it in the browser up until recently has been kind of annoying at points. And so you can check out this demo online at typescript-in-browser.glitch.me if you're also interested in it. But up until now, this has all basically been in the same vein, right? Polyfilling file formats, compiling stuff. What else could we do with service workers that's outside of this normal box of progressive web app functionality? Well, what if you were able to process data without it ever hitting the main thread of your application, or before it ever really was returned from the browser to your JavaScript? You can do that now. Right, when we think about the traditional model of fetching and processing data in JavaScript, it works like this. We have our JavaScript application, the JavaScript thread in our web browser. We make a request to an API or a CDN, and then we process it on the JavaScript thread. Now, many of us know that if you do this, it's fine for small data sets. But if you have a larger data set or a lot of complex processing that needs to happen, you run the risk of blocking the main browser thread and causing jank and an unpleasant user experience. And so oftentimes we're told to use web workers. But what happens if you want to process stuff that isn't coming from the JavaScript thread? Right? What if we want to do image processing or compile some code? Well, we can start to do it in a service worker instead. And all of our requests will go through the service worker, and we'll do the processing there. But if you wind up making a lot of heavy computations in that same thread, since JavaScript is single-threaded no matter where it's running, you'll run into the risk of blocking the service worker, which will actually create a bottleneck for your entire application and for every request that your page is making. And a lot of modern web apps make a fair number of requests. And so what if we could still use web workers to, again, offload that bottleneck? So you could actually do this. And instead, process the data in this manner, where it goes through a service worker, but on its way back, the service worker delegates that processing out to a web worker. And we do the processing there instead. And so let's talk about this idea, because it's kind of confusing, and it comes with a catch. Web workers cannot actually be created from service workers. And so we have to use a tricky workaround, which is kind of difficult to explain, so I think it's better represented by code. So we're going to start with this function transform that runs in a service worker. When you get a request, we do the same thing we did before. We go and fetch the original data. But at the same time we're doing that, we're going to ask the client that made the request to give us back a port object to go connect with a web worker. And so in order to do this, we need a client ID. And so that client ID is actually another property that's on the fetch event object. So nothing really special there. Inside the method to get our port, we're going to first get the client that is making the request using that client ID. And there is a client's API that's available in service workers that makes this relatively straightforward. Next, from this function, we want to return a promise because we need to do some asynchronous work here. And we're going to post a message to the client, which in this case is going to be our main application thread. And so this is really important to do because service workers are actually stateless. They don't retain global state over time because they can service requests from multiple tabs or multiple instances of a domain at once. And so if you have a web app that's open in more than one tab in your browser, you'll actually only be using one service worker instance, but it will handle requests from both of those tabs. And so we post a message to the tab that actually made, to the client that actually made the request. And in that client is where we will have created our web worker. And we will also have set up a message handler to handle that post message that we just got from our service worker. Now, inside this message handler, what we want to do is when we get that message, we want to create a message channel. And that message channel contains 2 ports, one of which we will send to the service worker, and the other one we will send to our web worker. Now, message channels are really interesting, but they're not super familiar to many developers because they're used only in web workers primarily at this point in time. And up until recently, a lot of folks haven't really worked with web workers because they're a little obtuse and the API is not super pleasant to use. But essentially what they do is they provide 2 ports that can both send and receive message events. And so all it allows you to do is communicate from one port to another. But the really interesting thing here is that these ports are transferable, which means that you can actually transfer them from one JavaScript execution context to another. So you can send them from your main JavaScript thread to a web worker, or to a service worker, or to a shared worker. And this allows you to easily communicate between the two, hence the name message channel. So anyways, we post one of those ports to our service worker. And then in the service worker, we receive that message channel and resolve our promise with it. That promise then passes that port back to our transform method. So now, once we have fetched the original data and have our port to the to the web worker for our processing, we can return a new promise, similar to what we just did, where we're going to take the port and post a message to it, this time with the data from our request. That sends it to the web worker. The web worker will eventually post a message back with the resulting data, and we can then resolve the promise and proceed. And so this is really awesome to me, even if it is kind of convoluted, because we can avoid creating bottlenecks inside our service workers. And so here's a demo of this technique actually running in the browser. First, we're going to start with a demo of what it looks like when you don't implement this technique. Right? We have some complex data processing that's happening, and while that's happening, we're trying to make a bunch of smaller requests. But we're actually only able to complete 2 requests in like a several second time frame, and that's really bad. I was on good Wi-Fi while I was doing this. But if we implement the technique that I just talked about, we can actually see that we're able to complete far more requests, 15 in roughly the same amount of time. So you can check out this demo online as well at service-worker-worker.glitch.me. Now there are a few concepts in here that are a bit confusing or maybe unfamiliar, so I would definitely encourage you to spend some time checking this out. I learned a lot putting this demo together and working on and through the ideas that I had in this. So one final thought, one final fun thing that we can do as service workers, and that is streaming data processing. This also is an unfamiliar API for a lot of folks because it's relatively new. But streams are exciting to me because up until now, the way we've talked about all these methods, all the things I've elaborated on, is that we have to download all the data first. And then, only after we've downloaded all of this data, can we begin doing any work on it. And so this is fine for small things. But if you're downloading a large, say, image or a video file, then you're going to wind up wasting a lot of time and a lot of memory because you have to hold that entire data set in memory twice while you do this operation. So this is effectively known as batch processing because we're waiting for all of this data to arrive before processing it in one batch. How can we make this better and faster, though? Well, for some use cases, not all, but some use cases, you can benefit from using stream processing, which is to say process the data as it arrives over time. And we can do this using the Streams API that I mentioned way back at the beginning of this talk. Now, if you're not familiar with stream processing, you might wonder how this helps, right? Because we still have to do the same amount of work on the same amount of data. So let's walk through the concept real quick. The idea is that we begin downloading the data same as we did before, but after we've downloaded a small chunk of it, we can begin transforming it, doing our work on that data. And as we do that work, we can download more data and transform that. And we simply repeat this process until we're finished. And the result is that we wind up getting a significant speed up because instead of doing all the work after we downloaded the data, we can do some of the work while we're downloading it. Now, up until recently, this was not a very easy thing to do in the browser by default. But we can now do it pretty easily with the Streams API. So if we take that polyfill function I had before from the very first demo, remember, we're fetching the data, waiting for it all to download, transforming it, and then returning a new response. We can change this function slightly, and so that we actually return a new response that's constructed from a stream. And we're not waiting for the data to download anymore. So let's step through this code, because we made a few substantial changes. The first thing we do is make a fetch, same as we did before. Next, we want to construct a transform stream with a transformer object, which is actually something that you'll define. And we'll talk more about that in a moment. But essentially, what it does is it provides the actual transformation that all this data is going to be streamed through. We can then take the response's body, the response that we got from our fetch request, and simply pipe it through that transform stream. Now, the body property is relatively new in terms of the fetch API, but essentially what it is it's just a readable stream of data. And so you note that there's no await that's happening here. We don't have to wait for this to populate, but as soon as we get our response, we can start listening to this stream of data. So it allows us to transform the content as it arrives over time instead of having to wait for it all. And so the pipe through method is simply going to say, hey, take that readable stream, pipe it through this transform stream, and give us back the result. And then finally, we construct a new response object from that stream and return it. Now this function is going to behave exactly the same as the polyfill function we had before, except for it will be faster and more performant and won't have to take up as much memory. So hopefully you can follow most of what I just said, but if not, this demo will also be available online, and you can go step through it and take a look at what is happening. So let's talk a bit about that transformer function, though. The transformer object can actually define a start, a transform, and a flush method. And all of these can be async, which is wonderful because it means that we can do promises and awaiting for stuff, which is handy if you're dealing with asynchronous tasks that need to be done. So the start method allows you to set up any state that you might need for your transformations. The transform method is then where you actually transform the data and will receive chunks of data over time. And then finally, you have the flush method, which is called when you're done receiving data and can do any cleanup or final processing that you need. So let's see this in action, because that's a lot of code. So this is similar to the demo I showed at the beginning of the talk, except for we're going to process the data in a streaming function. So we start with a broken image, we enable our service worker, and then we can watch as the data arrives and is decrypted over time. And you can see the image progressively rendering. And so this example is purposefully slowed down. I added a set timeout of 50 milliseconds in between each chunk so that you can actually see the effect happen. But this is exciting to me. We finally have first-class support for streaming data in the browser, and you don't even have to use it on the main thread. You can do it in service workers. You can do it in web workers. So at this point, before I forget, you can also find this demo online as well at cryptogram-streaming.glitch.me. So we've covered a lot of code at this point in time. And you can find all of this online, as I mentioned. But the specific details of the code and all the concepts that I talked about aren't the most important part of this talk in my mind. The most important part of this talk, and the real takeaway, is that we have so many awesome primitives and tools to work with on the web now, so that we can do way more than we ever thought we were able to before. Right, so these are some of the ideas that I've been mulling over and thinking about this year. But there are so many other possibilities out there, and I'm sure someone in this room, many of you in this room, probably have ideas of your own on how we can use these tools and techniques to push the web further. So whether it's using streams or service workers or WebAssembly or web crypto or other things that I wasn't able to talk about today, there's a lot that we can do. And I hope that it inspires you to be ambitious with your own projects. So I'd love to see what you've built and what you're going to build in the future. So go forth, experiment with JavaScript, have some fun, and make Atwood proud by just writing every application you can think of in JavaScript. Thank you. So we have some time for questions if anyone has any questions. I believe there's a microphone coming, so.
Thank you. Thank you for the talk. Yeah, it was really interesting. I'm curious about the compilation, the TypeScript and service worker. When you do that, in the debug tools of the browser, where are you seeing? Are you seeing JavaScript? Are you seeing TypeScript? If you put a breakpoint there, it stops really how it works.
So what you'll actually see, because what the browser has to actually process is the compiled JavaScript. You could enable source maps and wire up source map behavior so you get proper source maps while you're using that technique, though. But by default, you'll just get the actual JavaScript compilation. So,
okay, thank you.
Any other questions down here?
Really awesome talk. Thank you very much. So I'm curious about the hook of the fetch. How does it handle when the fetch, when the first resource made gets a max age in the HTTP request instead of doing the request again on a 302? Does it still get intercepted?
It depends, is the answer. So the behavior in fetch can be changed by a lot of different things, one of which being browser caching policies, as well as CORS options that have been set and the exact resource that's being requested. And so my best advice, obviously, is to just go try it out. Put a debugger in there, console log some properties out that you're interested in, and see what the behavior is. The exact example that you have in mind, I do not know the actual answer to at the moment.
Got another question, if I may. What's the support for older browsers with service workers, web workers, and all of this looks very beautiful on Chrome, but what about IE and all support?
Yes, so support varies. Most of the stuff that I demoed would not be supported in IE, but for the most part, hopefully you're beginning to drop support for IE because its market share is abysmal now, which is a great thing. But most of the demos should work in Firefox. I tested them there. Most of them should work in Safari as well, I believe. I can't think of any that shouldn't. And then Opera, surprisingly, also has really good support. And then Edge, hit or miss. So it depends on what your browser support policy is. Use your best judgment, obviously. But some of the techniques I talked about, like TypeScript, for instance, is primarily beneficial for development. I would not recommend doing that in production. And so if your development browser supports it, then go for it. But yeah, check out Can I Use for further browser support information about specific features. Some of the things that I talked about, like web workers, for instance, have really stellar support because they've been around for a very long time. Other things like the Streams API, for instance, is relatively new, and I think the specification is still undergoing changes to this day. And so browsers like Chrome and Firefox probably have the latest adaptations of those, but other browsers might not.
Thank you.
Yeah.
Nice talk, by the way. Are you using at Netflix right now the media converting process and service workers?
So at Netflix right now. So one note, I do not work on the main Netflix application. Need to throw that out there. And so as far as I'm aware, they are not using the techniques that I talk about in this video or in this presentation for any other videos that they're streaming. Who knows? Maybe in the future we will. But as of right now, no.
Thank you.
Any other questions? Okay, that's all. Thank you so much.